A page sat inside a Yale vault for over 100 years. Codebreakers studied it under lamps. Chemists tested it. Nobody saw what was hiding in the margin. Then an imaging scientist with no cryptography background pulled scans out of a decade-old storage drawer, scans nobody had bothered to finish processing. Something on that page had been sitting there the whole time, unseen. The manuscript nobody could read. The Voynich Manuscript is a real book. It sits in Yale University's Botanical Rare Book and Manuscript Library, cataloged as MS 408. Scientists at the University of Arizona radiocarbon dated its vellum pages in 2009 and traced the material to somewhere between 1404 and 1438. So the book is over 600 years old. The pages measure about 23 by 16 centimeters, small enough to hold in two hands, and the text itself runs to somewhere around 170,000 individual characters, grouped into roughly 35,000 to 38,000 word-like tokens. Every page is covered in a script nobody has ever read. The letters look like an alphabet, but they match no known language on Earth. Around that unreadable text sit strange drawings, plants that do not exist, star charts that do not line up with the known sky, naked women bathing in pools connected by odd tubing, circular diagrams historians nicknamed rosettes. Historians have grouped the roughly 240 pages into 6 rough categories based purely on these pictures, since the text itself has never given up a single confirmed meaning. Wilfred Voynich, a Polish book dealer, bought the manuscript in 1912 from a Jesuit college in Italy, part of a batch of 30 older manuscripts the Jesuits had put up for sale for financial reasons. That is where the book gets its name. He spent years trying to figure out what he had actually purchased, and it turns out he noticed something ODD on the very first page almost immediately. Before that first page ever entered the story, though, one page deep inside the book had already been quietly confusing readers with something even stranger than unreadable text, a drawing so large it had to fold out of the manuscript entirely just to be seen. The map that might not be a map. Tucked into the manuscript's cosmological section is a single sheet of vellum wider than any other page in the book. Unfolded, it spans roughly 6 pages worth of space and shows 9 large connected circles. The shapes historians call rosettes, linked together by pathways that some researchers compare to causeways or roads. Small drawings sit tucked into the design, including structures that look like castles, shapes resembling pipes or channels, and one form many researchers believe could represent a volcano. Nobody agrees on what this page is actually meant to show. Some researchers treat it as a cosmological diagram unrelated to any real place on Earth, tied instead to the same star and calendar imagery found elsewhere in the manuscript. Others argue it functions as an actual map, pointing to the castle architecture drawn into the design, including a battlement style called swallowtail merlins that architectural historians associate with northern Italy and the Alpine region during this period. Independent researchers and hobbyists online have proposed far more specific identifications over the years, including guesses that the rosettes depict a particular European city, though none of these more specific claims have gained acceptance among mainstream Voynich scholars, since matching a stylized medieval drawing to one exact real-world location is extremely difficult to prove either way. What everyone studying the page does agree on is that whoever drew it put real planning into it. The foldout was clearly built into the manuscript on purpose rather than added later, meaning the book's original makers considered this drawing important enough to require its own oversized sheet. That kind of deliberate design choice raises the same basic question that follows the manuscript's entire history from owner to owner. The question of who exactly held this strange object before it ever reached Wilfred Voynich's hands. The earliest solid trace of the manuscript's ownership comes from a letter written in 1639 by Georg Beresch, an alchemist living in Prague. Beresch described the book in his own words as a kind of riddle, uselessly taking up space in his personal library, and sent a sample of its script to Athanasius Kircher, a Jesuit scholar in Rome who had recently published a Coptic dictionary and claimed to have deciphered Egyptian hieroglyphs. Beresch hoped Kircher could work the same trick on his strange book. As far as anyone knows, Kircher never replied. Beresch's letter also passed along a story about how the book had reached Prague in the first place. According to that account, the manuscript once belonged to Rudolf II, the Holy Roman Emperor who ruled from 1576 to 1612, and filled his court with genuine scientific minds like Johannes Kepler and Tycho Brahe, alongside more questionable figures like the English astrologer John Dee and his associate Edward Kelly. The story claims Rudolf bought the book for a large sum of gold, believing it had been written by the 13th century friar Roger Bacon. Rudolf is said to have passed the manuscript to his physician, Jacobus Horsicki de Tepanek, whose name was later scraped off the first page, though it remains faintly legible today under ultraviolet light. After Horsicki died in 1622, the book eventually reached Beresch, and after Beresch died, he left it to his friend Johannes Marcus Marci, the same Prague physician whose handwriting would resurface on that first page centuries later. In 1665, Marci sent the manuscript to Kircher in Rome, along with a letter explaining that he believed only Kircher stood a real chance of reading it. Kircher kept the book, and it disappeared into Jesuit archives for roughly 250 years until Wilfrid Voynich bought it in 1912. None of these historical figures, an alchemist, an emperor's physician, and one of Europe's most celebrated scholars, ever managed to explain what the text actually said. That long, well-documented chain of frustrated owners sets up exactly why Wilfrid Voynich's own discovery on the first page mattered so much once modern imaging finally caught up to it. The faded line nobody could explain. When Voynich first examined the manuscript's opening page, he noticed the lower margin looked slightly off. Something had been written there once, then faded almost to nothing. Around 1914, he tried using a chemical reagent on the page, hoping the chemicals would darken whatever ink remained and make the old writing legible again. It did not fully work. The chemicals brought back a hint of writing, but nothing clear enough to actually read. Whatever had been scrawled in that margin stayed just out of reach, and the attempt itself left a faint trace of chemical staining on the parchment that conservators can still see today. For the rest of the 20th century, that faded line in the margin stayed exactly that, a smudge, a hint that something used to be there. Nobody had the tools to bring it fully back to life, so researchers moved on to other parts of the puzzle instead, chasing linguistic theories and botanical clues, while that one damaged corner of the first page sat quietly, unresolved. Then, decades later, a completely unrelated project quietly captured the exact kind of image that could finally crack this open. Nobody realized it at the time. 10 years in a drawer. In 2014, a team called the Lazarus Project got permission from Yale's Beinecke Library to take multispectral scans of 10 pages from the manuscript. Multispectral imaging captures a page using wavelengths of light beyond what the human eye can see, including ultraviolet and infrared. That extra range can pull faded or scraped away ink back into visibility, because old iron-based inks bite into parchment fibers even after the surface ink has vanished. The Lazarus team included Michael Phelps of the Early Manuscripts Electronic Library, imaging scholar Gregory Hayworth, map historian Chet Van Duzer, and camera specialist Ken Boydston, working alongside imaging scientist Roger Easton of the Rochester Institute of Technology. Together they scanned folios 1R, 8R, 17R, 26R, 47R, 70V1, 71R, 93R, 102V1, and 116V. The plan was to eventually publish the images online for other researchers to study, adding them to the small but growing body of multispectral work already being done on other damaged medieval manuscripts around the world. That publication never happened. The files sat unprocessed for 10 years, technically public property, but practically invisible, because nobody had put in the work to clean them up and share them. Raw multispectral data is not simple to read on its own. It takes real processing work to turn dozens of overlapping light wavelength captures into an image a historian can actually study. It took one email sent out of the blue in 2024 to pull those files out of storage and put them in front of the one person who would immediately understand what she was looking at. The email that changed everything. Roger Easton, who had worked on the original 2014 scanning project, came across an article written by Lisa Fagan Davis, the executive director of the Medieval Academy of America and a longtime Voynich researcher. He reached out and asked if she wanted to look at the old multispectral images. She said yes. Easton then spent about 3 weeks reprocessing the decade-old scans into a usable set of images, adjusting them so the hidden layers of light could actually be seen clearly by a human researcher instead of buried in raw data. When Davis finally opened the reprocessed image of Folio 1R, the manuscript's very first page, she described the moment as one where she may have actually shrieked out loud. The margin that Wilfrid Voynich had chemically treated a century earlier was no longer a vague smudge. It was readable structure. What she was staring at was not one column of writing. It was 3, sitting side by side, and none of them had ever been fully documented before. Before we go further, if you are getting value out of stories like this, subscribing helps this channel keep digging up mysteries like it. 3 columns in the margin. The right-hand margin of the first page contained 3 separate columns. The first was a plain Roman alphabet, running A through Z. The second was a column of Voynich characters, the same strange symbols used throughout the rest of the book. The third was another Roman alphabet, but shifted up by 1 letter compared to the first. So the letter that would normally sit in position 2 had been slid into position 1. Line those 3 columns up next to each other, and you get something that looks exactly like a homemade decryption key. Match a Voynich character to a letter, then check that letter against the shifted alphabet, and you have the basic skeleton of a substitution cipher, the simplest kind of code where one letter or symbol stands in for another. Simple substitution ciphers like this were already known and used in Europe by the time this margin was written, so the method itself would not have been unusual for someone of Marci's era to try. This did not mean the manuscript's actual text had finally been decoded. Davis was careful about that distinction. What she had found was evidence that someone, centuries ago, had also stared at this book and tried to break it open using their own homemade method. The columns were not the manuscript speaking. They were a reader trying to make it speak. Finding the tool somebody used to attempt a decryption is not the same as finding the answer, but it did leave behind exactly the kind of clue that could point to who that reader actually was. A name attached to the handwriting. Davis compared the handwriting in those 3 columns against samples from people known to have owned or handled the Voynich manuscript over the centuries. The closest match belonged to Johannes Marcus Marci, a physician and rector at Prague's Charles University who owned the manuscript from 1662 to 1665. Marci was a genuine figure in 17th century science, known for his own work on light and color decades before Isaac Newton published similar ideas, which makes his private attempt to break a strange cipher fit naturally with the kind of curious mind he already had. Marci is not a mystery figure invented for this story. Historians already knew he owned the book because in 1665 he sent it to Athanasius Kircher, a famous Jesuit scholar in Rome, along with a letter explaining that he believed Kircher had a better shot at cracking its meaning than he did. That letter is real and has survived. What nobody knew until 2024 was that Marci had apparently done more than just pass the book along. Before he shipped it off to Rome, he seems to have sat down himself and tried building a cipher key directly into the manuscript's margin, testing whether a straightforward letter swap could unlock the text. It did not work for him either, which is presumably part of why he eventually handed the whole problem to someone with a bigger reputation. But Marci's failed attempt turned out to be only the first surprise hiding on that page, not the only one. The second hidden text. Davis and the imaging team did not stop at Folio 1R. The same batch of reprocessed scans covered 9 other pages, and those images revealed their own quiet discoveries. Words that had faded into almost total invisibility on several pages became legible again under the multispectral light. Small details inside some of the illustrations, previously too faint to notice, also became clearer. One especially useful finding came from checking whether any of the 10 pages had been written on before, erased, and then reused for the Voynich text, a practice called palimpsesting. The scans showed no sign of that kind of reuse. That matters for dating the manuscript, because if the parchment had been recycled from an older document, it could have thrown off how confidently researchers can trust the 1425 date the vellum's own radiocarbon testing already points to. So the page that started as a single mystery, one faded line Wilfrid Voynich noticed in 1912, ended up containing layered evidence from at least 2 different moments in the manuscript's history. Marci's 17th century decryption attempt sat inside the very margin that Voynich's own chemical treatment had disturbed 2.5 centuries later, and the multispectral scans of the surrounding pages added even more previously invisible detail on top of that. None of this cracked the actual code the manuscript is written in. It turns out the first page is not even the strangest page when it comes to unreadable marginal writing. The very last page of the book has been confusing researchers for just as long in a completely different way. The last page that makes no sense, either Folio 116V, the final page of the Voynich manuscript, carries its own block of marginal writing, one that scholars have nicknamed Michitonese after its opening words. Unlike most of the manuscript, this text is not written purely in Voynichese. It mixes fragments that look like Latin, others that look like German, occasional Voynich characters, and small plus signs of the kind historians recognize from written prayers, where the symbol tells the reader when to make the sign of the cross out loud. The very first modern attempt to read this page came from William Newbold, the same University of Pennsylvania professor whose microscopic shorthand theory later fell apart. In the 1920s, he transcribed the opening words as Michiton Oladabus and built an elaborate cipher key around that reading, one that collapsed along with the rest of his Roger Bacon theory once other scholars examined his methods. In the 1970s, researcher Robert Brumbaugh tried a different approach, reading part of the same text as a scrambled reference to Roger Bacon's name, a reading most later researchers consider just as forced as Newbold's. Modern specialists studying the same page tend to describe it far more cautiously. Voynich researcher René Zandbergen and others have suggested the marginal writing might simply be what is called a probatio pennae, a scribe testing a pen or fresh ink by scratching out half-remembered fragments of Latin, German, and invented script, rather than writing anything meant to carry a real hidden message. Nobody has proven that theory correct either. The page remains, more than a century after Voynich first owned the book, exactly as contested as the moment Newbold first got it wrong. Between one page covered in a genuine decryption attempt and another page covered in fragments nobody can agree on, it becomes clear that confusion did not start with modern researchers or AI systems. It started the moment this book left its original scribe's hands, and it kept compounding every time somebody tried to physically rearrange or reconstruct the manuscript afterward. the book that was rearranged by someone else. The Voynich Manuscript, as it exists today, is not necessarily in its original order. Physical evidence on the pages shows a set of quire numbers, small numerals marking each gathering of folded sheets, written in a different, later handwriting than the main text itself. Those numbers suggest that at some point after the book was written, someone reorganized or rebound the pages, and that whoever added the quire numbers was working from an order that may not exactly match how the original scribes intended the sections to flow. The manuscript is also very likely incomplete. Some early records and physical evidence suggest the book may once have contained around 272 pages, compared to the roughly 240 that survive today, meaning a real portion of the original content is simply gone, lost somewhere across 6 centuries of changing ownership. Multispectral analysis of the surviving pages has confirmed there is no evidence of erased older writing underneath the current text, which rules out the idea that the manuscript recycles an older, unrelated document, but it does nothing to explain what was written on the pages that no longer exist at all. This means every theory built on the manuscript's current page order, including theories about which section came first or how the 6 categories relate to each other, rests on an arrangement that a later, unknown hand may have already disturbed. That uncertainty adds one more layer to a book that already resists being pinned down, and it sits right alongside the most dramatic and most publicly humiliating decoding attempt in the manuscript's entire history. The cipher that almost rewrote science history. In 1921, William Romaine Newbold, a professor of philosophy at the University of Pennsylvania, announced that he had cracked the Voynich Manuscript. His method was unlike anything tried before or since. Newbold claimed that if you examined each individual character under a microscope, you could see tiny shorthand marks hidden in the ink strokes themselves, and that decoding those microscopic marks revealed passages written by Roger Bacon, the same 13th century friar named in Marci's old letter to Kircher. According to Newbold, Bacon's hidden text described scientific concepts far ahead of his time, including descriptions that sounded like a telescope and a microscope, instruments that would not be invented in Europe for another 300 years. Newspapers ran the story. Voynich himself toured the United States, promoting the discovery, telling audiences it would prove that medieval black magic actually consisted of scientific breakthroughs centuries ahead of their era. The theory did not survive scrutiny. After Newbold's death, fellow scholar John Matthews Manley examined the same pages and concluded that what Newbold had identified as deliberate microscopic shorthand was nothing more than natural cracking in the old, dried ink. Cracks that happen to any centuries-old manuscript and mean nothing on their own. Manley called Newbold's claims baseless and said they should be rejected outright. There was also a much simpler problem nobody could get around. A cipher built on microscope-level shorthand would have required Roger Bacon to have invented the microscope himself in the 1200s, centuries before anyone else in recorded history built one. Newbold's collapse did not end the Roger Bacon theory completely, but it did teach later researchers a hard lesson about seeing patterns that are not really there. A very different kind of evidence, this time coming from actual botanists rather than cryptographers, would end up delivering an even bigger blow to the idea that this book came from medieval Europe at all. The plants that should not exist yet. If the Voynich manuscript really was written in early 15th century Europe, every plant drawn inside it should be a plant that existed in Europe at that time. In 1944, botanist Hugh O'Neill looked closely at 2 of the manuscript's illustrations and identified them as a sunflower and a capsicum pepper, both plants native only to the Americas. Neither species reached Europe until after Christopher Columbus's voyages at the end of the 15th century, decades after the manuscript's vellum has been radiocarbon dated. O'Neill's identification was largely ignored or dismissed at the time. Decades later, botanist Arthur Tucker and researcher Rexford Talbert revisited the question in a detailed 2013 study and extended the list dramatically, identifying dozens of plants in the manuscript as either native to the New World or otherwise absent from medieval European botanical texts. Later work by Tucker, alongside horticulture professor Jules Janik, pushed that count even higher, eventually cataloging well over 100 plant-like drawings across the manuscript that matched no known European species from the period. This creates a genuine contradiction for anyone trying to pin the manuscript's contents to Bacon or any other pre-Columbian European author. A sunflower cannot appear in a book finished before anyone in Europe had seen one. Not every scholar accepts Tucker and Janik's full identifications, since matching stylized medieval drawings to specific real-world species is difficult and inherently open to disagreement. But the core radiocarbon dating of the vellum itself is not in dispute, and it already rules out the more dramatic versions of the Roger Bacon story, regardless of what the plants turn out to be. What the botanical debate does confirm is that the manuscript's actual subject matter is just as unsettled as its language, and that uncertainty runs in more than one direction at once. Two different languages hiding in one book. Long before AI or multispectral imaging entered the picture, one of the strangest discoveries about the Voynich Manuscript came from patient, page-by-page comparison. In the 1970s, cryptologist Prescott Currier, who had worked alongside William Friedman studying the manuscript, noticed that the handwriting and letter patterns were not uniform throughout the book. He identified two statistically distinct writing styles, now commonly called Currier Language A and Currier Language B, that show up in different sections of the manuscript. The two styles are consistent enough that later computer analysis has confirmed the split holds up statistically, not just visually. Some researchers think this means two different scribes wrote different portions of the book, possibly working from the same underlying language or system, but with slightly different habits and conventions. Others argue the split could reflect two different stages of composition, or even two related but distinct dialects of whatever the underlying text actually represents. Whatever the explanation, this was hard evidence, discovered decades before any headline-grabbing AI or university press release claim, that the manuscript's text has real internal structure, rather than being uniform gibberish, copied out once from start to finish. That structural evidence sits alongside every other headline-making claim about the manuscript's meaning, and lining all of those claims up side by side shows just how far the field has come without actually reaching an answer. What this does and does not prove. The Voynich Manuscript's core text is still completely unread. That has not changed. Cryptologist William Friedman studied it for years, during and after World War II, and never solved it. British codebreaker John Tiltman, who worked at Bletchley Park, also failed. More recent public claims have not held up well either. In 2019, the University of Bristol issued a press release announcing that researcher Gerard Cheshire had cracked the code, describing the text as an extinct language called Proto-Romance. Lisa Fagan Davis herself was among the scholars who publicly called that claim unreliable, and Bristol pulled its own press release within a day. A year before that, University of Alberta researchers Greg Kondrak and Bradley Hauer used an AI system to argue the text was scrambled. Hebrew, but medievalist Damian Fleming and others pointed out the final translation leaned on Google Translate, a tool trained on modern Hebrew to interpret 600-year-old scrambled text. A separate researcher, Stephen Bax, once claimed to have worked out 10 individual words, including plant names, but even he admitted the wider text remained far from understood. Statistical studies keep the mystery alive because the script genuinely behaves like real language. A 2013 study confirmed the text follows Zipf's law. The same mathematical pattern found in every known natural language, where a small number of words repeat constantly while most words barely show up at all. Random gibberish typically does not follow that pattern. Some researchers, like Gordon Rugg, have argued the text could still be a mechanically generated hoax built with a device called a cardan grill, though that device was not invented until 1550, more than a century after the manuscript's vellum has been dated, which leaves that theory with its own unresolved timeline problem. Add Newbold's collapsed shorthand theory, the still unresolved New World plant debate, and the unsettled quire numbering to that list, and a clear pattern emerges. Every confident claim about this manuscript, whether it comes from a 19th century philosopher, a modern AI lab, or a university press office, has eventually run into the exact same wall. The Marci discovery does not settle any of that debate. What it proves is something narrower and, in a way, more human. It confirms that at least one real historical figure sat down with this exact book, built himself a decryption tool, tested it against the text, and walked away without an answer, just like everyone who has tried since. So what do we actually know now? The first page of the Voynich Manuscript has now given up two separate secrets. The first is Wilfrid Voynich's own 1912 discovery of a faded inscription, later chemically treated but never fully read. The second is Johannes Marcus Marci's homemade cipher key, invisible for centuries until multispectral scans taken in 2014 finally got processed a decade later in 2024. Neither discovery tells us what the manuscript actually says. What they tell us is that the book's mystery has always run in two directions at once. Modern researchers keep trying new tools, from radiocarbon dating to AI language models to ultraviolet imaging, while historical readers going back hundreds of years were doing the exact same thing with whatever tools they had available at the time. Even the manuscript's physical shape keeps adding new open questions, from a folded map nobody can place to a final page of scratched out fragments nobody can fully read, to a page order that a stranger's hand may have quietly rearranged long after the original scribes finished their work. Lisa Fagan Davis has said the newly processed scans still show additional faded text on some of the other 9 pages that has not been fully studied yet, which means this specific research thread is not finished. The manuscript remains exactly where it has sat for years, inside a climate-controlled room at Yale, still unread, still radiocarbon dated to the early 1400s, still waiting for either a real translation or a final proof that there was never anything to translate in the first place. If you want more deep dives like this one, subscribing costs nothing and keeps this channel chasing down stories exactly like it.